Take a look at the solutions to your concept check that you just wrote on from Unit 6, Chapter 5. The very first question is very straightforward. You're going to be using your graphing calculator. Enter in the data under the Edit category, and then use one variable stats to be able to calculate it. And remember that when you look for that answer, you're going to find that it's written as the following symbol, and it will tell you that the actual standard deviation for this one is 12.0. Now for this one, it's talking about a set of data that's normally distributed, and it says what percent of the data is within 2 standard deviations of the mean. So when you're doing something like that, you want to draw a really quick sketch so that you can remember, okay, here are my standard deviations and these are the percentages. What you want to look for is within 2 standard deviations. So you're going to be looking from between -2 to +2. And you're going to be adding these numbers together, which many of you know already, but when you add them together, it will give you 95%. Now, the second version of the quiz had a similar one, except it asked you to find just within 1 standard deviation of the mean. And so for that one, you're just going to be doing between 1 and -1. And so you would say it was 68%. Normal curve A has a mean of 5 and a standard deviation of 12. That's the most important part in this question. Normal curve B, so this guy was A, with a standard deviation of 12, and normal curve B has a standard deviation, I'm kind of jumping over the other, of 5. It asks you to describe which curve is more dispersed or spread out. And remember, we discovered that when the standard deviation was high, that the data was spread further away from the mean. So the curve was very dispersed or flat. And so in this question, we're looking at an answer of normal curve A because the standard deviation is higher. Now, the second version switched those numbers. And so normal curve B had the standard deviation of 12. So your answer was normal curve B. Okay. The ages of professional golfers in a local tournament are normally distributed, very important thing to see, with a mean of 35 and a standard deviation of 5 years. What percent of golfers are between 30 and 40? So again, you're going to want to have a graph. And this time it wouldn't hurt to actually label it with the actual numbers because there's a mean of 35. And then as you move along, they change by 5. So this is 40, this is 45. And the last one would be 50. And then on the other side, it's going to be 30. And then it goes down to 25 and 20. Now, in this question, they're asking you to find out what percent of golfers are between 30 and 40. So you're going to be doing between 30 and 40, which is 68%. Now, I believe the second version, if I'm correct, I believe it was between 30 and 45. So you go from 30 to 45. So you are adding another 13.5 onto your answer, which is why your answer would have been 81.5. You should see that marked on your version of the concept check. Determining the z-scores for something. Well, straight ahead, you're using your formula of the z-score, which is equal to the value of x minus the mean. Remember, we use that new symbol for the mean, divided by the standard deviation. And you have those values, 235, you have 4.5, and you have x. And so you're simply using those numbers, plugging them in, and calculating a result. Now, here is the first one that was actually the most tricky one. And this one involved, if you look at it, it says determine the percent of data. Now, what's tricky about this is the next one, to the right of the z-score. Now, they gave us a z-score of 0.82, but they want us to find the probability to the right. And remember that your z-score tables only tell you the probability to the left. So if you're using your z-score table and you know that your z-score is 0.82, so that it's somewhere here, you know when you look it up that your z-score of 0.82 is going to give you the probability of everything to the right of that line that you're doing. And so let's go and look it up. It was a z-score of 0.82. So 0.8 is here. There is 0.82. So 79.39. So when I look at this guy, I have this percent is 79.39%. Now, you've got to watch out because the actual text of the question did not ask for the left. It asked for the right. And so to be able to find that, you take this number and subtract it from 100 to find this side of the graph. This one's pretty straight ahead. It says find a z-score that corresponds to this area. The only thing you've got to watch is that it's given to you as a percent. And so you're going to change it to 0. You're going to move your decimal place 2 places. So 0.0918. And you're simply going to use your z-score tables. And so you're going to go, sorry, I've already forgotten what it was. 0.0918. Okay, 0.09. If you look along here, okay, here's the 0.09. 0.0918. Huh? So we look, and this one gets, there it is, right there, actually right on the nose, negative 1.33. And so you have a z-score here of negative 1.33. Okay, this one, you're asked to find the data between two z-scores. So you're supposed to be looking in here. All right, you're finding the data in here. So you've got two z-scores. Use your z-scores to find the probability. Whatever those probabilities are, when you find those percentages and you can calculate what they are, then you simply subtract them so that you can find out what the difference is between them. And probably you'll put the larger one first so that you don't end up with a negative probability. Okay. Don't let word problems make you think that something is hard. There's just some simple stuff going on in here. Nutritionists measure the sugar content for 12 drinks at Starbucks coffee shop. The drinks had, here we go, a mean of 18 and a standard deviation of 5. If the data is normally distributed, very important, find the z-score when you're looking at 17 grams. So you're going to be using your z-score formula. Z is equal to x minus the mean divided by the standard deviation. And so then you have your equation. The z-score is what you're looking for. The x is the value that we're testing, so it's 17. Our mean is 18, and the standard deviation is 5. Okay, so you plug that all in and find an answer, as you see above. Now, this one is the one that's probably one of the complicated ones, along with the one that looked at the data on the right instead of the left. When we talk about z-scores, and maybe I'll bring this up for a second. When you talk about these z-scores, these numbers, remember these are specific locations on a set so that you know where you are in relationship to the mean. If you have a z-score of 1.2, you know that you are 1.2 standard deviations above the mean. If you have negative 1.9, you know that you are negative 1.9 standard deviations below the mean. So it's all about this. The z-score tells you where you are in terms of the standard deviations. And then the z-score table gives you the probabilities or the percentages of the data to the left of the z-score. So when you look at the question that they gave you and they said, how do we interpret what we just found? We found a z-score. How do we interpret it? Well, it is the number of standard deviations this drink is below the mean of the 12 drinks that they started with. So it's 0.2 standard deviations below the mean. Okay, next one. Now this one is more about, most of you knew sort of what to do. You just need to tidy up your work a little bit. First of all, I've given you some numbers, asked you to find their mean. This version is 10.5, the second version is 10.2. But then, most importantly, and this one was worth 3 points, I wanted you to calculate the standard deviation. And I want you, this is the second time I've said it, show all of your work. Not some of it, but all of it. In order to calculate the standard deviation, step number 1, you list all of the numbers. And you don't have to put them in order, just list them. Once you have them, make sure you indicate what their mean was or their average. Third step, take each one of those numbers and subtract the mean from them so that you can see how far away they are from the mean. Fourth step, take all of those differences that you found here and square them. And remember, a negative 4.4 times a negative 4.4 is never a negative. It's always positive answers down through here. Fifth step, once you've found all of those numbers, you must find the average of those numbers. And lastly, you're finding the standard deviation by taking the square root of this number. So there are a number of steps involved. If you had missed recording some of those, then you lost points on that. Okay, so be very careful about the process as we go through. A question like this one, where I'm saying, assuming the data is normally distributed, label the following curve. Well, if you're labeling them, what we're looking for is that the mean comes in the middle, and then you're doing standard deviations away. 1 plus 2 plus 3. So you give the actual values of the numbers. It's not a bad idea as well to indicate what each one of these values would be worth, like we've seen in some of those others. So remember, you're kind of dividing it into sections. This one would be 34. The next one is also 34, and then it is 13.5 on either side, and then it is 2.35 on either side, and 0.15, and so on. Okay, I don't think you need me to write it down because you guys have been working on memorizing those. That's just a quick description of what's expected. So here's a quick view of the second version. Of course, pause the video if you need to, but notice, list the numbers first, find the mean, then find the difference between the numbers and the mean. Then square the numbers. Make sure you show what the mean is of these numbers, and then the standard deviation to finish off. This last one as well shows you how you would have done the table, the labeling the curve so that you can see the mean and then each standard deviation. The other last thing was, if you look at the text of the question, they wanted you to find it to the 2 decimal places. Okay. Question number 2 was the same in both questions, a standard question, something you definitely have to be able to do. If you go through and look at what they give you, car dealer determines the mean, and the mean is 65, and the standard deviation, 4.5. What guarantee should the dealer give so that fewer than 15? So we want to know to the left of 15%. We have our mean, we have our standard deviation. Our percentage is written as a percentage, so we need to change it into a decimal so we can use our z-score table and figure out what our z-score is. If you look it up, you'll realize that it's negative 1.04. Plopping the numbers in so that you can find what x is, it turns out that x would have to be 60.32. Now, when it comes time, remember, you have to put a sentence to finish, and there's not a single car company that's going to say it's 60.3. They're going to round it, and they're going to round it down. So the guarantee should be about 60 months. You could have also said 5 years if you chose to as well. The next one was, there were actually 2 ways you could have found it, and I gave you credit for both. You didn't have to do both, but just if you did it one way or the other. The assessed value of housing in Kentville is normally distributed. Very important thing for us to realize they're telling us. And then it says the mean is 180 and the standard deviation is 10,000. And then we're supposed to find what percentages of houses have assessed value between 160 and 190. So first thing, you could have used a number line. Put your deviations in, fill in the actual numbers. You're going from 160 to 190, so you can see that you're adding it up to 81.5. Second version uses z-scores in the tables, calculates a z-score for the first one and a z-score for the second one, and then finds their probabilities and subtracts them, getting an answer of 81.85. 2 different answers, just by a little bit, and either one was correct. Here's the second version. This one was similar, except it went from 170 to 200. So you can see that your z-scores were slightly different, but the percentages are exactly the same. Okay, the last question. Now this question was very similar to number 14 in your homework. So if you look at number 14, you're going to see something that's very similar to it. You'll remember as well that we had to push things a little bit to make sure we could get our assessment done by Friday. And so as a result, the homework that you did came after the concept check. Usually I have more time and I can give you that question before you try it, but just so you'll have some extra practice, take a look at number 14 as well. Now, here we go. The national results for the SAT test show that 30% of students scored higher than this number. So when they tell you that 30% scored higher, remember if you're really thinking about where that is on the normally distributed graph, you need to think of it as 70% scored lower. So this 70% scored lower goes with this number. Whereas when they told you that 70% of the students scored higher than that number, you want to think of it as 30% because you want to think of the one which has the data to the left. Okay, now that's where the trick is in this question. But beyond that, if one of them is 30 and one is 70, if you think about where 30 and 70 are, exactly half between these two, between 30 and 40, would be 50%. And we need to know what the mean was. So if we took these two numbers and added them and divided them by 2, we would find the mean. And that is what we start with. The mean is 1,083. Once you have that, now we need to find the standard deviation. And so I'm going to use this number and I'm going to consider it as the Z-score where it plunks at 70%. So what I do is I think, okay, 70%, that means I'm looking for 0.700. I find out that the Z-score is 0.52. I plug it in, I have my number, I have my mean, and I just have to move things around to be able to find my standard deviation. It turns out my standard deviation is 210. Okay, so there you have it. That is basically the concept check in a nutshell. I will also post these solutions online so you can see them. But good luck as you get ready for your assessment.